Hey y'all, it's Dr. Know-It-All. Today I want to test out Gemini 2.5 Pro Preview 506. So this just came out yesterday. It is a new version of Google's Gemini 2.5 Pro. I actually have not tested 2.5 officially on this channel yet. I don't know why. I was just busy at the time and then I was like, it's old news and everything. But now there's a new version, so this is a great excuse. I'm going to test out several things that are much more complicated than I have done before. But I'm going to start with a question that most of the LLMs have failed thus far, just kind of a general sense of the world, reasoning, physics-based question that I ask, and all of the non-reasoning models and most of the reasoning models actually fail to get this question right, so I'm just going to start with that and we'll see how Gemini does. All right, so I'm going to read this while Gemini thinks about it and answers this. Alice drops an olive into a clean glass and then fills that glass with water exactly to the brim. She then places a piece of stiff cardboard on top of the glass and deftly flips it over, placing the glass upside down on a completely clean and dry table, resting on the cardboard. She then, and we've got an answer already, she then deftly removes the cardboard from beneath the glass, leaving the glass sitting directly on the table and not spilling a drop. Bob later enters the room with no knowledge of what Alice did, and seeing the glass with the olive in it, picks up the glass and places it in the dishwasher. What is the state of the table now? That should be wet, whereas the olive, it should be on the table or on the floor. And did the glass need to be placed in the dishwasher? A little bit of a red herring, but anyway, we'll see what the answer is. So first of all, it thought for 16 seconds and change, and we've got the setup and everything. So let's see, what is the table, the state of the table now? The table is wet. Very, very good. All of the water from the glass spilled onto it when Bob picked up the glass. Excellent. Where is the olive? The olive was inside the glass with the water. When the water spilled out onto the table, the olive would have spilled out with it. So the olive is on the table in the puddle of water. Excellent. And then we get to the question of whether it needed to be in the dishwasher. And this is actually a fairly nuanced answer. While it has been, quote, used, it is not particularly dirty in a way that would require a full dishwasher cycle. A simple rinse would likely have been sufficient. So no, strictly speaking, it probably did not need to be placed in the dishwasher. That is a perfectly excellent answer. That is awesome. So next up, a question that ChatGPT o3 crushed. I want it to make me a 3D snake game where either optionally via a key press, either I can control the snake or an AI agent can control the snake. So let's see, we'll go ahead and run that. And just so I can run it myself on VS Code or something like that, we'll go ahead and say use Python for that. I'll just add that to it. So it's thinking for a little bit here. And if we want to look at the thinking, there is quite a bit going on, and it's actually going fairly quickly. I don't know, what, 10 to 20 tokens per second, probably a little faster than that. So it's kicking along at a pretty good pace, and there comes the code. So it's actually writing out the code. Wow, very, very cool. I'm going to collapse this, and I want to see what the ultimate answer is when it gets done. So the response is, this is a fun challenge. That's kind of cool. Create the 3D snake game. Here's the code, printing it out for me. So interesting. I don't know if it wrote it twice because it looked like it was... yeah, it actually wrote the code, and it looks like it's writing the code twice, which seems a little bit wasteful, but such is life. All right, so we've got the code that I just copied, and we've also got instructions on how to play it. Press R to restart, Q to quit. Okay, so we'll switch over to VS Code and give it a shot. So as you can see here, we've got 304 lines of code. That's a pretty decent chunk of code, and we will go ahead and run this. Alrighty, so I did not have Ursina installed. I don't even know what Ursina is, but I have installed it, and let's go ahead and see if we get something to actually happen. Alrighty, and oddly enough, it opened up a Python file, but it was an resizable, unmovable window, and it's not on my second monitor, so I couldn't show it to you. And also the scale, the size was like way off. The snake was like huge, and it was running off the window. So anyway, I specified this, and I said that the game looks like it's blown up. I would consider that a very loose feedback, but we'll see if it's actually able to understand this and come up with an answer that fixes the problem. Alrighty, and this comes down to Ursina, which I don't know. I don't know that package at all. So it says that it will fix the problem. So here are the key changes, and we will see what happens. It's reprinting it for me as we speak. Alrighty, so let's go ahead and fire it up again. And okay, now we've got something. Okay, so I'm going to try to restart, press R to restart, and then C to have the, oops, we'll press R to restart and C. Here we go. Let's see if it actually, It seems to be disappearing. I'm not exactly sure where it is. Oh, so interesting. That's weird. So it seemed to disappear for a minute. I don't know if it got below the sort of ground plane, but there's sort of an invisible, yeah, it looks like there's actually something that ground plane is hiding it. But let's see if the food reappears there and if it will actually show up again. So it seems to be working. There's just that weird ground plane that's causing the issues, but that would be a 3D snake game that the computer is controlling. So it seems to be doing a pretty good job on, just unfortunately, there's that ground plane there. So let's see if we can repeat something that Matthew Berman did that was actually it was actually shown in one of Google's recent keynote speeches. Sundar presented, I can't remember which one it was, but that was pretty amazing that it was actually shown there. So I'm going to ask it to make a Rubik's Cube simulator. I'm not even going to bother with trying to solve it myself. That would take way too long. But basically you press K to scramble the cube to any arbitrary state, and then S will use an algorithm to solve the cube from its scrambled state to a solved state and allow the cube to be anywhere from 3 by 3 by 3 to 20 by 20 by 20 blocks. Okay, so it actually says that it is achievable. The scramble is achievable. Solving a beginner's method or even a more advanced but still complex method like CFOP can still be implemented for larger. Solving includes reducing the cube to 3 by 3 by 3 by solving centers, pairing up edges. Okay, I mean, there we go. What I can provide realistically, this is fascinating here. So anyway, again, it's using Ursina. This is interesting. I'm going to have to look up what your Ursina is. I am not sure, but anyway, my robot vacuum is out there. Not the good one. This is the one that's down in the basement. If you haven't seen my review of the Matic cleaning robot, the vacuum and mop, it's up here. I have an old stupid one that I use in the basement that just goes around and cleans once in a while because it's, the basement doesn't get used all that much. So anyway, if you haven't seen that, it's a really cool review of the product. And I think it's the first actually smart vacuum cleaner ever. In the meantime, interesting that we've got lots and lots and lots of commented stuff in here. So fascinating how it's doing that, but we will wait and see see if it's actually able to make this in a single shot like Matthew was able to do. So that'll be really cool if it is. All right, so we have 554 lines of code. That's actually significant. And we have an error. Oh, bummer. Okay, so I'm going to throw the error in there. I just copied and pasted it. So here it goes. It is actually reprinting this and explaining the fix. All right, so we'll fire it up again. And here we can see left mouse button, click and drag. So I'm going to press the K key, which should hopefully scramble it. And there it goes. Oh my. This is definitely not working as well as Matthew's. So let's see if we can we rotate around this thing? I don't know. All right, so I did a screen grab and said, yikes, scrambling does this, please fix it. So we will see if it's able to fix it. This is not impressing me quite as much as I was hoping, because I was hoping it would just be able to get it like that, no problem at all. All right, so apparently, I love the responses. It's very funny the way it responds. But accumulating floating point errors and transform issues when dealing with reparenting and rotations. So that seems reasonable to me. I mean, just at a rough guess. And I looked at some of the thoughts. It thought extensively. That's 90 seconds it thought. It thought for a minute and a half, which I think is longer than creating the original code was. So actually, it reduced the size of the code just a little bit. So we will take a look over here and see... All right, so yeah, that didn't work and the scramble doesn't work. Let's see, we can try T for reset to solve. Okay, we can try K for scrambling. Yeah, okay. Less than stuff. That's really interesting. Like Matthew had such a good, no pieces found for slice X. Let's just go ahead and type in S and see if it attempts to solve it. Yeah, it seems like it's, yep. So unfortunately, that's a thumbs down. It was unable to fix it after several attempts. All right, so now we're going to try something a little different. I'm going to take a video from 3 Blue 1 Brown where he actually does feed forward networks that happens around the 5 to 6 minute mark in his video. And I'm going to see if Gemini can understand this and just recreate it from the video. So I'm very interested to see if it will be able to do this. So fingers crossed. If it can do this, that's a pretty big game changer, because that means you could actually like just have it watch a video or look at pictures or something like that and actually recreate parts of it. So again, I'm not explicitly giving it the video. I'm giving it the YouTube channel link and telling it where it is in the video and having it go look for itself. So I'm giving it a pretty hard task here. So I'm very curious to see what happens. Let's see what its initial thoughts are here. So it's actually creating code already. So understand the goal, wants to recreate the visualization around the 5 to 6 minute mark, break down the visualization, tokens, feed forward blocks. So it's understanding the basic assignment. Again, Ursina, what is Ursina? I'm going to have to look this thing up. Data representations, initial code structure, mental draft. So it's making a draft of the code, refining the implementation. Okay, I mean, so really, really cool what it's actually doing here. And now it's actually writing out the code. In the meantime, I'm going to go find out what is Ursina Python. So let's find out. Ursina engine. It is a Python-powered open source game engine. Okay, well, I guess I'd always just used Pygame, but I guess maybe Ursina is better, or at least it's something that Gemini tends to prefer over Pygame. Alrighty, so we're going to go ahead and copy this over to VS Code, and we're going to see if it actually works. I'm very curious. And we got an error here, so I'm going to copy and paste, and we'll see what it does with that error. So we're going to go ahead in here and swap out that line and restart it, and we will see if we have some luck. Nope, no luck again. All right, so it came up with a whole bunch of solutions, like a lot. And I'm like, I don't feel like going through and copying and pasting. So I'm asking it just to fix it for it, just retype the whole code here for me. All right, so one more time and one more break. Ah, bummer. All right, so last time, if it doesn't work this time, I'll give up. But I really wanted it to work, yeah, and it didn't work again. So, okay, so no such luck on that. That's a bummer as well. Geez, I'm not having nearly as much luck as other people are at having this thing work well for me. All right, so this time I'm actually going to have it write me a prompt to actually help it create a better piece of code here. What I want is a simulator that will show off the difference between classical Newtonian physics and Einsteinian general relativity physics with a single point mass or a single mass in the middle of a solar system like the sun that you can dial up in size in terms of mass so that it becomes like a black hole or something like that with a Schwarzschild radius so that you can see a photon, following a Newtonian path versus a photon following an Einsteinian path to show off the difference between those two. So it's a significant question, but I want it to be able to help me to create a prompt that will make this even better. So yeah, as you can see, it's creating from my prompt here, it's creating a much more substantial prompt, and I'm just going to copy and paste that back into the LLM and see if it's able to create me something amazing. Okie dokie, so I'm just copying and pasting that prompt right back into it, and let's see how it does. Fingers crossed it'll be amazing. All right, so as you can see, it's very excited about this. It's a fantastic project. So we will see it. So weirdly enough, it got stuck in a loop of creating yet another prompt. So I'm just going to be like, hey, yo, I want you to make this. So we'll be back when it gets done. All right, so it's got a whole bunch of rules about how it's working, and it's got C is set to 50, I guess, as opposed to 1. So it should go nice and quick. So let's see, save the code, make sure you have Pygame, run from your terminal. You should see a window, adjust the sliders, and click Launch Reset to see the photon paths. Increase the math significantly, log 10 mass 3 to 6 to see the strong general relativity effects and the event horizon appear. So let's give it a shot. So we got an immediate error. This is way less impressive than I thought it was going to be. I thought I was going to get all these things like straight out of the box without having to have all this error thing where it goes back and forth. This is where having an LLM agent is way better than what's here. In other words, if I could just do this and it would like generate the code, run the code, get the errors, see the errors, fix the errors all on its own. So I didn't have to be involved in this, but now you can see apparently it's a very, very simple fix. So we'll give it a shot. All right, so we'll comment that line out and give it a shot. Ah, man, another error. All right, apparently we have something here, launch reset. So I'm not seeing a photon here. Let's see if we can increase the size of our pause. Launch reset. All right, so I copied the image and I gave it my feedback here, and let's see if it works. I'm getting a little bit frustrated with Gemini Pro 2.5. I've got to say, after all this time with all the reasoning models and everything, the one model that works the best is Claude 3.7 Sonnet. In fact, actually, I'm kind of curious. I'll probably on my own actually put this into Claude 3.7 Sonnet and see how it does. It just seems to be so much better. And I don't know, people have talked really, really highly about Gemini 2.5 2.5 Pro and how well it does with code, but I'm just not seeing anything that's just blowing my mind. And it's more annoying than it is amazing. So one thing I will say is it's definitely very nice. You're absolutely right. The previous code laid the groundwork, but missed several key elements. So photon visibility, that is a pretty important thing or else you can't see it. The event horizon, launch the vector indication, and UI layout, spaced out UI layouts, slightly better. So that's cool. Anyway, it is now typing this up. When it gets done, I will copy and paste it back into VS Code and we will try this again. Okay, so it added about 70 lines. Let's go ahead and fire it up and see if we have, I'm still not seeing anything. Let's go ahead and say launch. New. Definitely not seeing anything. Let's speed up the simulation. Launch, reset, pause. Nope. And let's see if we actually see a black hole mass. Yeah, no, I'm getting nothing. All right, so I'm going to go ahead and end this video here. I am definitely not very excited about Gemini 2.5 Pro in terms of programming and stuff. That is supposed to be its wheelhouse. I admittedly gave it difficult things to do, but it failed to generate the code on the first try. It created a bunch of errors that I then had to go and, have it correct and all of that kind of stuff. And except for the 3D snake game, I never was actually able to get anything that I was particularly enthralled with, or honestly that even worked okay. So I'm just really not that impressed with Gemini 2.5 Pro. I wish I was much more impressed than this because other people have had really good luck. But compared to Claude 3.7 Sonnet, I just don't think this even holds a candle to it in terms of my own experience with it. So your mileage may vary. Definitely let me know in the comments what you think if you've had a different experience. But in the meantime, I'm just going to have to give this a downvote. I don't find it directly usable and it's more annoying than it is useful. Alrighty, folks, so that's what I've got. Let me know in the comments what you think about all of this. If you enjoyed the video, please like it so other people can find it and consider subscribing for more of this kind of content. And I will see you in the next video. Bye-bye.